Hello. Hello. No, we're good. We're good. People are going to quiet down, I'm sure. Over in the corner, troublemakers. All right. Gentlemen, you need pizza? Guys, thank you for coming out. We're hoping to have more of these coming forward. I'm kind of standing in for John, who was originally supposed to speak, so I apologize if I'm looking at my phone for dates, but we just wanted to make a quick mention to next month. We're going to have the Docker birthday party. That's going to be March 21st. We're looking for mentors of Docker. So if you want to like push up your game on Dockerizing and Dockerizing all things, we want you to come and kind of join us and start talking about it and start thinking about what we need to know to basically push it towards people that may not be well geared to the Docker users themselves yet. And then, so I also want to thank Cars.com for hosting the venue here. This is our first time here, and really appreciate it. A little bit quick hands for the Cars.com people. And really appreciate everyone coming. If what we're trying to do, and I know we've been kind of sporadic on the RSVPs and all that, so what we're going to try to do is be consistent going forward. If you need to change your RSVP, try to be diligent on that so we can make sure that new venues know how many people are coming and all that, so we don't have extra pizza that I have to take home. Again, just March 21st, so it's coming out really soon. So anyone that's interested in, I mean, even if you're not well equipped, but at least you've played with Docker, we want to have you get in touch with us. Just message the organizers that, hey, you're interested in being a mentor. We're going to ramp up some kind of process and try to get you guys geared up to be ready to field questions. And then what we want to do is really focus on, last year, I don't know if anyone was here last year for the Docker birthday party, we were at Groupon's headquarters and we went over, we were all trying to just patch bugs. It was kind of a good time. But regardless, what we want to do is, the mentors I think are going to probably gain more than the people learning or we're supposed to be teaching. So hit us up. With that, I actually don't have anything more, so I will hand it off to Cars.com. We're looking for a fantastic talk. I've already heard a little bit of it. So
bathroom.
Oh yeah, yes. And the bathroom is anywhere you see a dark corner. I heard. No.
Keep it in the trash cans.
Behind you to your left, if you're facing the house, and in that corner. Or again, corners work too.
Seriously, with the corner, we prefer it in the trash can. No, and all. So hello, thank you guys for coming out today. My name is Keith Kreisel. I'm Principal Developer. Working in this environment, but it doesn't work in this environment. So then I started looking. That's my cue. I started looking, I'm like, well, here's the architecture document. What can possibly go wrong? I mean, it has everything listed here. I mean, where's your problem at? But then I started looking, and I was like, wait a minute. I think our architecture is more like this. Now, as you know, most applications that you're working at, most companies, they have multiple environments, right? In our case, our tech stack includes IBM and Oracle HTTP servers. We have IBM and Oracle WebSphere and WebLogic. We have Java JDK for both Oracle and IBM. Then we have different operating systems for our servers, which is Red Hat Linux and Oracle Linux. So as you start seeing, it starts getting really, really complicated, right? So then we got into automation tools such as Chef and Puppet. Now those tools are very helpful for helping keep server drift, but we still see a lot of problems because it's not just one production environment. We have all of our non-prod as well. So now if I have a problem, I have to go look, okay, is it application? Is it the web server? Is it the HTTP server? Or is it a third-party thing that Chef introduced? Not that Chef is a bad thing. Chef is just a very complex tool that's really built for a complex problem, as we see right here. So enter the immutable infrastructure. What we're really trying to strive for here at Cars.com is encapsulating our applications, our runtimes, and our OSs all within one artifact. We want to have predictable builds and deployments. We want to be able to say, when I deploy something out in one environment, it's going to be the same in all of our environments. We also want something that's scalable. We get a lot of traffic, and at times we get different spikes. We don't want to have to worry about a spike and then say, oh, I got to spin up a server, I got to spin up a JVM. How much do we spin up? Using immutable infrastructure, I hope to just spin up a new artifact and have it handle all that traffic. It might be more than one. Okay, don't quote me on that. And then, of course, no one wants to get a call in the middle of the night and say, hey, something's broken. We want to be able to say, hey, if it's broken, just roll back to the previous version. We'll go look at it tomorrow. So how can we get this all done? What is the best thing? And this is really where I believe Docker comes into play. So why Docker? Well, it's hot right now. It's everywhere. You see it in GitHub. You can see it almost in every documentation. Everybody's using it. Everyone's doing it. Everyone in here is doing it. And if you're not, there's mentorships, as we just heard. So get on it. It's great. It's a lot of great documentation. It's really easy to set up. So if you're working as a local developer, it's very simple to use your Windows machine or OS X. And before they had the Ubuntu Docker, but now it's Docker machine. So much simpler, so much better. State isolation. I can't say anything better than this. We don't have to worry about what is happening on our actual servers, right? Everything's encapsulated in our one image. So that way we don't have to worry about any third-party dependencies. With our deployments, when you'll see later, what we're actually achieving with our deployments is actually containing all of our applications in that one image, and then we can just deploy out containers. By doing this, if we have any problems, we can roll it back or go forward to another instance. We don't have to worry about anything else. I already talked about the recovery. And one of the big things that I really think is going to shine, especially here with our UX and product, is our blue, green, and canary releases. By using this kind of approach, we can easily send out different versions of our software to our customers and our users of our website without having to worry about the rest of the site. So for example, if we want to release a new piece of our code out to 10%, we have 10 containers running. All we have to do is change out one container. So now that you've heard all the benefits of immutable infrastructure and how Docker can help, I'd really like to tell you about how it actually works in practice and how we were actually able to achieve this. As I said earlier, we were primarily a Java shop. But then we started looking, we're like, what would be really cool to do in a rendering platform is let's do it in Node. And then on top of that, might as well do it in Docker Node. So that's where we came up with this. Now you don't have to understand what's going on here to see the big picture, but what we're going to show you today is how we were able to achieve our rendering platform running on Node, living in Docker. So now I'd like to hand it off to Z, and he's going to give you some more background on it.
Hello everybody, good evening. My name is Latko Šisić and I'm a senior developer for Cars.com. So Keith kind of gave us an introduction about some issues that we are facing and what we are trying to do in the future. And I would like to tell you how we really started with Docker. So probably like everybody else here, when we heard about Docker, we just wanted to try the tool, see what it can do and how it can apply to what we're doing here today, or have been doing. So we built a group and tried it out. So we started pulling different images, full Linux distribution, well not full, but Linux distributions such as Ubuntu, CentOS, Debian, different runtimes that we were using, Java, Tomcat, Node. So variety, and everything looked great. We had a variety of Unix tools already pre-installed on the system. We had pretty stable package managers, Yum, apt-get, that we could utilize. And the most important thing is we really wanted to use JFrog Artifactory integration with those package managers so we can cache all the packages and we can also kind of control the access to what packages get installed. So that was our goal and everything looked good. We tried a couple of applications and decided it was really a tool to go. So after further discovery, we noticed that images were pretty big. Knowing how Docker works with their layering system, it isn't really a big issue if you're constantly redeploying to our servers or to our infrastructure, but if you're spinning off new environments on the fly, it would be an issue because there is a certain time that it has to take for those bigger images to download. So, and then especially if you're a developer working from home over VPN and trying to pull a new image after destroying and recreating a virtual machine, you would have a lot of fun probably researching a couple of new sites, right? So, also another thing we noticed was that most of those Linux distributions had majority of tools that we needed for our applications, but there were some missing. So either way, we would further have to tweak the distribution to build our base image. So we made a decision, we're going to build a cars.com base image with exact tools that we need that we can reuse, that pretty much any team at cars.com can reuse. So started looking at something smaller. So first we used BusyBox. Great distribution, very small, depending on the actual flavor that we're using. Very robust, tweaked for Docker, but problem with BusyBox was that it did not offer most of the, or some of the tools that we were using. So in order to get them up and running, we would need maybe additional compilers or more tools that we have to install. So we would inflate the image sizes. And then again, it didn't have any package manager. So we jumped to Alpine, being a derivative of BusyBox. Alpine, on the other hand, had a package manager, APK, which we could use. So we could easily, or we were able to integrate Alpine package manager with JFrog Artifactory to cache all the assets, have them on the side, so every time we have to rebuild our images, we wouldn't have to go out of our network, and the actual download times would be very fast. So at the end, we created a base image with all the tools, all the utilities, using Alpine Linux. We standardized the set of tools, so literally every team has is probably going to find everything that they need to find in that base image. We integrated with Artifactory, and we drastically reduced the container sizes. So as you can see, some of this data, it might be a little bit misleading, but as of today, I actually had a couple of developers also verify this. They can look at the node image. I mean, it's about 650 megabyte, and people would not believe me. Tried it out, pulled it down. It was literally 650 megabyte versus the image that we are using, it is working fine, is about 55 megabytes. Same thing with Java, same thing with Tomcat. So we were able, using the base image, we built, or using a base image as a derivative, we built flavors for different node versions, for different JDK, JRE versions, OpenJDK, Oracle, Java, Tomcat on top of that. So we did create a nice foundation of base images to use to actually ship and package the application. So this is our JFrog. Oops. 1 second.
Sorry about that.
Yeah. So basically, I would just like to show you what we have used, how we use the JFrog Artifactory. And here you can see some of the base images that we created. It can be pulled down and literally used to package and ship our applications. Also, another thing was the APK, the registry, the APK manager registry cache. So here are some of the instances. We just recently purged the packages, but usually once that gets populated, we have a copy. Yes. They're not public at the moment, but we are thinking about actually pushing them out. There are some other tools that we're trying to get through legal to basically set up. So we are in process. So I think we're good. So this is how we started. This is how we built the images. We have the application, we have the images, and I would like to invite Mac. He is going to show us how to actually use everything to the code. Oh, question. Go ahead.
Are you guys using Artifactory as your image repository?
Yes. Yes, of course, Docker, yeah. Internal
Can you repeat
Docker
the
repository.
question?
If we were using Artifactory as an internal Docker repository, the answer is yes.
It's a little foreshadow for what you'll see later in the presentation.
Hi, I'm Matt Keller-Ogden, a senior developer here at Cars.com. And I want to talk a little bit about our build and deploy framework. So we looked at the landscape and we asked ourselves, what tool do we want to be using for builds and deployments, right? So the problem that we faced when looking at that question is that the initial development has not really settled for these tools. They're still in flux. There are a lot of really great options, and I'm pretty sure we're going to use one of those good options in the near future. We have Kubernetes, we've got Docker Swarm, Docker Compose. They're all very great tools. There are other options out there as well. But we wanted to buy ourselves a little bit of time before we settled on one of these solutions, and we said to ourselves, well, what are our immediate needs? What can we solve right now without locking ourselves into a specific tool? We just need to be able to handle a few simple things. We want to handle scaling up and down, dynamic port allocations, rolling deployments, a few other basic kind of Docker things. We don't have the need to run thousands of containers in production right now. We have a few simple use cases, and so the other thing we wanted to solve was in order to achieve an immutable infrastructure, you want the same tool on your developer's machine as you have on your build server, right? You want the same tool that's doing those builds, you want the same tool that's doing the deployments. Because even if the images are all the same, whatever's running them, whatever's building them, it needs to be the same as well if you're really going to be immutable. So the other piece was, okay, these projects, these applications, they need a configuration. We want a very simple declarative syntax for these projects, something that can be fairly concise and just tell me exactly what I need and keep all of the repetitive logic of the builds and the run process in a central place, right? So I thought to myself, and I'm a big Bash guy, like I'm a big Vim guy. I like software from the 70s. I thought to myself, this should be a makefile. And I looked around and everybody knew it. It should be a makefile. That's all we need right now. That buys us enough time, right? Make is a really great tool. It allows you to compose a series of targets, run things in a kind of centralized way. It has a lot of really great tools. We don't need to get all makefile-y right now. But I will tell you, I wrote a makefile that does Docker orchestration. I had to size it down to a 3-point font, so I don't know if you all can pick that up in the back. But yeah, this worked great, and I thought that's kind of a problem. Because if we commit this with every one of our projects, that doesn't meet one of our goals, which was to have a simple declarative syntax, right? Well, the good news is that you can include makefiles inside of makefiles. Awesome. And the good news is that if you override any of the variables in a makefile, and you've included a makefile before that, it'll just use whatever you overwrote. So we can keep everything in that one centralized makefile and then use this. And then the other key to making it all work is we wrote a very simple entry point script that wraps around make, and we called it powertrain. And powertrain will set this variable for you. And then you can just override a few variables. There are actually about a dozen of these things that you have the option to set depending on your needs in the project. This is a very simple example where we're setting the application name, Docker registry. This is a web container, so it needs to bind a port. So there's the default port. And then to keep things really, really simple for now, we're deferring all of the run logic to a script. And then you can specify the location of that script so that when you say, hey, I want to spin up 10 new instances, it knows just to run that script 10 times, and every time to allocate a new port if it needs one, a few other fancy magical things. But we were able to meet all of our immediate needs with this, and we were able to get out to the glass a whole lot faster than it would have taken to define an entire strategy around one of the existing tools.
Hey, seems like a lot of talks going on. How about we get a demo going here? Would you like to do a demo for us, Mac?
I would love to do a demo.
You have to hold this while you talk.
I don't know. I can't type with one hand. It's one of my weaknesses.
Oh, it's gonna be great when
I'll go get the prices right, Mike.
Do you want me just to live talk it while you're typing?
Hey, you can talk.
No.
No. Yeah, we didn't plan this part.
Try and talk.
I'm just going to talk loudly. Everybody can hear me? All right. So this is the Node.js project that we were talking about. This is our new rendering platform. And if we look in the root of this project, there's a makefile. It looks suspiciously like the one that we were just looking at in that slide. There are just a few extra things. We're not actually using these extra scripts anymore, which is why I pruned it down in my example there. But you can see it's just including that powertrain makefile, that huge 3-point font slide, and then specifying a few things that we already talked about, right? So keep that in mind whenever we run any of these commands. The entry point script for powertrain is on my path, so I can run it from anywhere. And it's doing a couple things. One is that it's figuring out where you are. It's going to look in your current directory, and it's going to say, hey, is there a makefile here? If there is, I'm going to use it. If there's not a makefile there, it's going to look and say, was there a project directory specified? And if there was, it's going to CD over to that directory, and it's going to try to use that. If neither of those things are true, it's just going to use the default makefile that's inside of powertrain itself. Because you don't necessarily need a project in order to do this. You could just be pulling from the registry and running it yourself, right? So the first thing I'll do as part of our demo here is to build and publish. Now, part of the power of make is that you can chain together all these targets. I could chain 13 different, and targets are just tasks or goals. You can call them whatever you want. In official make-ease, they're called targets, right? So I'm going to say powertrain build publish. What I want to do really quickly to help explain that is show you the powertrain makefile itself. And if I look for this build target here, you'll see that it's going to run a build script. And if I look for publish, publish is a composite task. It's actually going to tag the image and then push that image. All right? That's as codey as we're going to get. I'm just going to stick to the commands for now. So when I do this, it's going to build out a new Docker image based on the latest commit in this repository. It's going to tag it, and it's going to push it up to our registry. Right? And it's going to know what to name it, and there's a version script in there that's going to actually use the latest git commit. And you can specify however you want to get the versions for things. If you don't want to use a git commit for your version, you can specify a script that it's, the goal of that script would be to tell you what version to use, so you can use whatever logic you want, right? In this case, I've already built the project, so it built super fast, and I've already pushed the project, so it pushed super fast as well, but that's what it's doing, right? So now, I want to run this. Instead of just using powertrain run, which I could do because I built this locally, I want to demo the deploy target. And what that's going to do, it's another composite task. It's going to first pull the image out of the registry, and then it's going to run that image with however many instances I specify. By default, just one, but I'm gonna have it do more. And then it's going to go ahead and wait for a little bit. You can use a sleep target, and the default on that is 10 seconds, but you can override it to whatever you need. That gives the containers time to warm up if they need them. And then it's going to do a stop old. Stop old will tear down anything that was there before it, right? So that's the powertrain deploy. And instances, I'm going to spin up 4 new instances. So the first command ran very quickly, pulling. I already had it, so it just verified that it was up to date. and then it ran 4 new instances. It's now waiting for that 10-second warm-up period, and it's going ahead and stopping the old containers. They should come down right about now. All right. So if I look at my Docker processes, I have 4 new containers up. The line gets wrapped because we're on this display here, but you should be able to see that under ports, we have these port mappings, and the default port that was in that make file is set to 1337. So it's just dynamically allocating more ports starting at that point, going up. It's actually checking your system to see if they're available and registering them. It skips ports that aren't available. What I'll do next is I'm going to, instead of manually using one of these composite tasks that hides all the magic from you guys, I'm going to use a few targets explicitly. I'm going to say powertrain run, and I'll go ahead and I'll use that sleep target, which is going to give us a little warm-up buffer, and I'll stop old. These are some of the same things that deploy was doing, just minus the pull. And I'll spin up 4 new instances. This is that 10-second warm-up period.
By adding the stop old, did you just destroy the 4 previous instances you spun up?
That's a good question. There are a lot of different ways you can work with this. When I'm using this without adding any additional arguments, it's going to assume that I want to stop anything that was there before that is of the same name, but not necessarily the same version. You can control that behavior, though. We can, if we have time at the end, we can follow up a little bit more on this. I'm going to look at the Docker processes again here with Docker PS, and you'll see that this time it climbed up. It spun up these containers while the other containers were running, so it had to run them on higher ports. And then it tore down the old ones. So it starts at 1341 and goes up through 1344. If I were to run that again, and I'm just going to take the sleep out because we don't really need that for our demo, you'll see that it actually recycles the ports. It goes back down to 1337. It tries to be as smart as it can about using available ports. So there's back down to 1337. There's 4 new instances. We spun up new ones. We tore down old ones. That works great. For local development, you probably want to manage all of your running containers. You want to manage all of your exited containers, your images, your dangling images, all of this kind of stuff. We have commands for all of that. There's actually, you can even manage processes in here. I can say Docker PS, and it's just going to show me very specifically the processes that have to do with this, the application of this name. It's going to limit your PS output in case you have a lot running on that host. So I'll go ahead and do powertrain stop, and that's going to stop anything that matches this exact version, this exact name plus version by default. Again, all of these can be overridden with inline commands. I could put a different version in here, but for now we're just going to do this. We'll stop everything that we started during the demo here, and if we look at our Docker host, there's no more processes running here. So this is just scratching the surface. We've done quite a bit with this tool, but this shows you kind of some of the power of this on the local machine. This exact set of scripts is running on all of the Docker hosts that we have as well. And what Deep is going to show you next is how some of this is working in action in our Jenkins server. And what's that? What's the light?
All right, thanks, Mike, for the demo. My name is Deep Mistry. I'm a senior developer here at cars.com. I'm also part of the newly formed CI/CD team here, working with Keith. And what I'm going to talk about right now is how are we using Jenkins as our CI and CD tool, and actually deploying all these containers into our environments. So what we have right now as a process is, oops. All right. So obviously we're using Jenkins as our CI tool. So what we have is like the project that Mac just showed, our content rendering Node.js project. So we have so every time you check in something into that project, so whenever you commit and push it up to our internal GitHub servers, it actually triggers a Jenkins build job. And that build job is pretty much running the same powertrain scripts that Mac just mentioned. So we have powertrain distributed to all our build servers, in this case Jenkins, masters, and slave servers. And that powertrain distribution is happening using Chef. So these build servers are smart enough to know how to run my powertrain scripts. So that build job, what it's doing there is it's actually pulling down the latest from the Git repository. It's gonna look at the Docker file and then create the new Docker image, and it's gonna tag that image with the build number of the Jenkins job and also the Git commit which you just pushed. So.
Would you like me to push this up?
Yeah, sure, go ahead.
All right, I'm going to push a small change to this repository for Deep so we can demo the pipeline.
Yeah. So this should actually trigger our build job. Should be up here in a minute. So it's in the build queue. I'm sure you guys are familiar with Jenkins. So our build job is currently running, and like I said, it's utilizing the same powertrain scripts that Mac just talked about. It's going to build this image and push it out to our internal Docker registry, which is hosted on the JFrog Artifactory registry. So the good thing about this is now we have an image of a version of this application, which is already in our internal registry, and now we can take this image and deploy into our subsequent environments. We can put it to dev, FT, whatever environment, and that is how we are trying to achieve the immutable infrastructure here. So looks like it's trying to push to our registry.
Okay, you want to check that build number?
It's 266. So that's the convention we are following. Like I mentioned, we are tagging these images as the version being the build job number which Jenkins just built, and also the git commit of the code. So as you can see, we have this image now available onto on our registry, and then you can also I know you guys saw this before, but one of the cool things about the Artifactory Docker registry is you can just go over all the layers. It tells you how much size every layer is. So it's kind of neat for some of the debugging purposes. So like I mentioned, we are using Jenkins for our CI. So the build job is also going to trigger the deploy job. By default, the build automatically kicks off the deploy to the dev servers. So now the dev server, obviously it's again a Jenkins build. And what this build is going to do is it's going to pull up the same image that we just pushed, and then start those containers using that image. And to start those containers, obviously going to use the powertrain scripts. So now powertrain is also available on our Docker host. And then when we start these containers, we give them the name of the application and the version and the number of instances we want to run. So it started fairly quickly. So now we have about 4 containers running on our dev environment. So now let's say if you want to push this to our FT, the feature testing environment, we can simply just click on that button, and Jenkins will trigger one more job and distribute that code onto our feature testing environment. Right. So now when we started building this whole new infrastructure, we were also building a whole new tier within our company. So we didn't have any. These are all brand new Docker hosts for us. There are new virtual machines for us as well. There was no way to talk those new Docker hosts to talk to our internal load balancing technology, which is the big IP local traffic manager. So we were trying to find I thought it was written by the guys from HashiCorp, and it's a little Golang service. What it basically does, it listens to Docker events on your Docker host. So every time you spin up a container, that event gets registered with the registrator, and then you can configure that registrator to work with multiple backends. I think out of the box it supports etcds or SkyDNS, console, all those backends. But that is something that we didn't want to use. So what we did was we wrote a new backend for registrator. So we wrote a BigIP backend. So now we can start our registrator process on every Docker host and telling it to use BigIP as our backend. So now we use BigIP's REST API to dynamically register any new container that spins up with a new BigIP pool. So when those PowerPoint scripts are running and when they spin up new containers, those containers are getting registered with our BigIP pool using that registrator. So now we have our users can now reach our new containers easily and dynamically. So when you kill those containers, the registrator will also deregister them from BigIP. So that is how we achieved the immutable infrastructure here. So far it's been a good journey. We're learning a lot. We're also improving a lot. We are gonna, so I guess for closing statements, I'm just gonna hand it over to Pete. He's gonna talk more about sorry, go ahead.
Is that menu back into it?
It is not currently publicly available because since BigIP is proprietary, we just wanted to talk to them and see if we can do that. But we're hoping it should be able to.
What was the question?
I'm sorry, the question was, is the new backend for registrators publicly available?
So the BigIP REST API though has all of the documentation that you would need to do everything that is there anyway.
Right,
and
sure.
Yeah.
I'd probably not do it.
Fair.
Yeah. So I mean, technically we cannot call it a BigIP backend and just call it a REST API backend and just like make it publicly available.
If the actual Docker host goes down, how do you handle stale entries in BigIP?
So if the Docker host goes down and let's say we bring up the new, you mean the new stale entries in the registry?
Yeah.
The BigIP?
Well, if the Docker host crashes, then the registrator's not there to remove the entries.
Yes, they will still be there, but then BigIP is smart enough to check that they are not reachable. So it's going to remove them off the pool.
Just help
So
check.
that's
So it's a health check.
There's a health check.
Okay.
Yes. That is, I think, by default is available.
Excuse me, what exactly is your health check? Is it by, is it?
I'm sorry, there are two questions here. Sorry, go ahead.
Sorry, yeah, what exactly is the health check in this case? Are you making a turn request, or is it by just ping, or?
As of right now, we're just doing a ping. The question was like, what is the actual health check from BigIP to these containers? Right now, it's just a simple HTTP ping. Just any.
We have it on our roadmap to make that better though.
But that is something you can configure on BigIP. You have questions here?
Oh, I was just asking, it just takes it out of like the pool or something, it takes it out.
No, they just marked as inactive. So then
Question.
next time you start the
Steve,
bring
what
up
was
the
the
Docker
question?
host.
Say the question.
Say the question again?
Oh, sorry, I need to remember that. The question was like when the Docker host goes down, BigIP marks them as not part of the pool, but it does not remove them from the pool. They're still there. They're just marked as inactive. But the good thing about it is if you bring up the Docker host back up and then you start the registrator again, it's smart enough to check that those members are already there. So if you start a container with the same IP and port number, it's not gonna try to add them again. Cool. All right, so I'm gonna hand it over to Keith.
So now that you've seen what we've achieved just with our simple node applications, and I talked a little bit earlier today about, we are a Java shop and all of our services. What is the future of Docker here at Cars.com? And my future of Docker at Cars.com is actually moving all of our Java processes off of WebLogic, off of WebSphere, and into containers in themselves. In fact, I want to take it one step further, and I want to just make sure that we have containers that can take incoming web requests and respond appropriately. because then it doesn't matter what's running inside the container. We can run any language we wanted to. So if the problem we're trying to solve will be solved better with Golang, I don't have to run a crazy 3-month POC and show how it's better than Java and do all this. What I can easily do is just build it, put it in a container, put it out there. In fact, using canary releases, we can put 50-50, 50 running the old Java and 50 running Golang. Or maybe it's Scala, or maybe it's Play. And then see which one performs better, and whichever one wins, then that's the one that wins out. I think it just opens up so many more possibilities, and the tool belts that you have as technologists in here to try new things without having to convince everyone it's the right approach to go. Let's see what else was there. You know, I was going to say one other thing. You know, the other thing too is like we're really striving for continuous delivery here, and we really want to get stuff out to the glass faster. And having immutable infrastructure and having Docker in place, we'll have the confidence to move faster, to push stuff out faster. And if there are problems, who cares? We'll just roll it back or fail it forward. It makes things so much easier and so much less stressful for the developer. It actually makes it more fun, in my opinion. So with that, I want to thank everyone for showing up. You know, we'll answer some questions, but we do have a GitHub account, cars.com on GitHub. Powertrain is available if you would like to have Powertrain. We are looking at doing the registrator and some of the other features that we're doing, which have to pass through legal, and those should be out there as soon as possible. Any other questions, feel free to email us at immutable@cars.com. I know there's the mentorship groups, but we'll be listening on this email address too. Or if you want to see us personally, if you liked one of us better than the other ones, feel free to give us a shout out. So that's all we have. So any questions? Oh, right there.
For immutable infrastructure, what implication does that have on troubleshooting in your live environment? If you've determined that it's not related to the image, the image that you propagated everywhere, it's specific to one box, one server, do you just mark that as inactive and you don't even bother to troubleshoot it? Or what do you do?
That's a very good question. So we haven't had that problem yet, so I don't know. No, I guess, you know, it depends. Right now, since we are running everything on-prem and on virtual machines, we'd probably dig into it. But I would think, like, if we were running AWS and EC2, we could probably just shut down that whole thing and just spin up something else, and then maybe, or just take it out of the pool and investigate it that way. But we'd have to look to see if it's, like you said, if it's not part of the application, it's something else, then of course we'd have to dig into it.
If I can add, one thing that Docker is giving us is it's limiting the options for what else might be wrong. And we are controlling so much now that what might be wrong is a very small set of things. So it's a lot faster and easier to look into that.
Did that answer your question?
Yeah, so does that mean that most of your troubleshooting then is in improper packaging or improper distribution of an image or the load balancer rather than what's inside the Docker container?
Well, we can still have problems. We can still have bugs, right? So we do use Dynatrace in-house, and we have very special logging set up. And we use Splunk to see where these problems occur. And we're, like Mac was saying, with having it all encapsulated like that, we can check there first to see if it was the application. If it was the application, then it's very simple. We just create a brand new container and shoot it out there. Otherwise, then we have to dig a little deeper. Go ahead.
So I was saying this earlier to some folks, but Brian Cantrill of Joyent, they use Docker very heavily. They use containers very heavily. He has an excellent talk called "Running Around Debugging Containers in Production," where he talks about taking a core dump from the container and then killing it. Right. So now you have that core dump that you can analyze and dig into as to what went wrong, while still restoring stability to concept.
Can I make a comment on that? So one thing that we built with our Node application that directly correlates to that is that if there are any uncaught exceptions, in Node you're able to listen to the uncaught event, right? And we have two different layers handling that. One that fires immediately and binds a handler, a very simple handler, and then we have one that fires later that will actually go to all of our standardized centralized logging with a once handler. But what happens is we take a core dump, and we get a stack trace, we get as much data as we can, we dump it out, and then we exit the process. As soon as that happens, the container goes down, registrator pulls it out of the pool. So we are doing something very similar.
So what happens when the host goes down? Big AP marks that host as unavailable, and you still need to restore kind of availability of the application.
You wanna handle that
what
one?
spins it up? What spins host back up?
Sorry, repeat the question.
Yeah, so the question was, if I get it right, so if one of the hosts goes down and, actually, I'll let you repeat it. Would you like to come up here and grab the mic? So we can I wasn't even gonna try.
So what will happen if the host which runs the application goes down? I assume Big IP will mark it as unavailable and will not route traffic to that host, but what process or what solution will spin up required amount of application instances back on another host, I suppose?
Yeah, so that's a very good question, and the simple answer is we don't have anything right
No, we do. His name is Ken.
So we have a view to but no, that's probably the direct effect of us not using a real orchestration tool. We're just using Powertrain to manage, instances, but it's not smart enough to say that, oh, this went down, so I should spin up some more instances. But we have, like Mike mentioned, we have a lot of good monitoring available using Splunk dashboards. So we would know pretty quickly that this thing is down. So, and then Ken is going to go ahead and start.
Well, there's automated shell scripts that go in and monitor via Docker PS to check which ones are up and running, and then
Right. Yeah. And
That guy too. That guy too.
Do you want to say that to Mike?
Sure.
Mike, do you want to
Mike,
talk
finish
to Mike?
everyone.
Our orchestration tool.
Yeah.
I didn't write it, but there's some stuff using just like basic Docker PS where it's checking to see which ones are up and running and a certain number of hosts that are, containers that are up and running. And as soon as it notices that they're down, it'll spin up new ones. So it's a very basic, similar kind of makefile bashing thing.
I just want to add one more thing to that is all our Jenkins jobs, they can be triggered using just from scripts using URLs. So that script can potentially just call one of the other jobs to just spin up one more container.
What percentage have you migrated over to Docker, and for the remaining percentage, what's preventing you from Dockerizing those infrastructures?
So I would say what, 1%, 5%? It's a new technology here. Cars.com, we like to try to say we're in the front, but we still have a business to run here, and we're still, it takes a little bit of time to get things moving. But as what you can see, what we've already laid down the groundwork, I foresee us moving down this path a lot quicker than it was starting up to get our foots in the door, right? So I would hope to say by, hopefully by the end of this year, we have a lot more of our infrastructure running on there. We are exploring the cloud right now. We are looking at AWS. That's another reason why we're not going full throttle into this right away, because we don't know what our cloud solution is going to be, and right now we're running everything on our own virtual machines. So every time we want to send up more capacity, we have to allocate more virtual machines for the time being. But once we have that available, then the sky's the limit. Then it's just, hey, who wants to go on this next?
So you guys mentioned Kubernetes and things like that at the beginning. So at what point do you start looking at that to solve some of these problems?
We're looking at it right now.
We're looking at it.
We are. No, that's a very good question.
Can you repeat the question?
The question was, man, you're gonna make me repeat it again. We said we were looking at Kubernetes and Mesos and Swarm, and what's gonna make that determination of when we do it or when do we start looking into that. And we are currently looking at it right now. It's just that we only have this one application running on it. So that was the main driver point for even having Powertrain in the first place. Because imagine bringing in Kubernetes, you have like a bazooka to kill an ant, right? It didn't make much sense at the time. But I think we're actively exploring each one of those options, and we'll see where it ends up.
Can I say one more thing? I think that I think a lot of companies are probably in a similar position. I mean, we've been around since 1998.
We are, that's why I'm asking.
We have all these technologies. We were able to, in very short order, get Docker on the glass. And the way that we did that was we accepted our limitations. We knew that it was going to take a long time to define our strategy. We knew that those tools deserved some respect. We needed to consider them properly. So we scripted out some options and we're out there. And I think that's a legitimate path for any company if you're going to have an iterative development approach. So yeah, we're definitely we're gonna land somewhere with an enterprise tool. But I hope that you can see what we've done, right?
Yeah,
So.
How did you tie into your monitoring framework, both on the container level and the applications running in containers?
So the question was, how did we tie into our monitoring software frameworks? You want to take that one because you did too?
Yeah.
I mean, you want to do it? Who wants to do it?
Right. So there is a Node.js agent for Dynatrace that we have evaluated. We're actually not using that quite yet. We've designed a few of our own very simple monitoring tools, mostly using Splunk for the moment. It gives us near-time monitoring, and then we have, again, a kind of makeshift scripted solution that will give us some health checks and let us know what's going on. There is a long-term solution though. We are looking at an APAS solution with Dynatrace, and we're looking at some other. Most of our monitoring will be through Dynatrace in the very near future. We have a good relationship with them, and we're going to be using the Dynatrace agent. But most of the monitoring right now, like I said, is in Splunk. We have some dashboards that give us near-time data, and we have some scripted options that help us keep track of things.
You mentioned that you found some missing Unix apps on the base Docker images. What were those?
Z, would you like to? The question was, when we were using the base images, we found some missing Unix apps. What were they?
So just to be precise, they were not missing apps, they were still available in the repository where we had to go and install them. I mean, depending from distribution to distribution, it could be, I mean, wget curl, something very simple that maybe zip and so on. So there was, I don't know if we had anything specific for each one of the distributions.
Yeah.
But pretty much using the package manager, we would be able to install it. But that led us to a belief in the actual direction where if we really have to use the package manager to install those additional tools, we should really concentrate on reducing the image sizes and then building out the actual image ourselves.
Do you use single process or multiple process in one document?
Do we use single process or multiple processes in a Docker container? And we use single. We did look at, with Node, what was the process manager?
PM2.
PM2. But then we decided it would be just easier for us to do is just have one running Node process within that container and just spin up a bunch of containers instead of having it split all out inside of it.
It simplifies the orchestration concern. Then you don't have to worry about process management and Docker management. You just have one process per container and you manage containers. And that's it. So.
What's your backend storage technology?
The backend storage technology, for our images or just data in general?
For your application.
For the application. So our applications, we are running on an Oracle database right now. So all of our applications, well, the rendering tier makes web requests into our Java applications that are running in WebSphere or WebLogic, and then they communicate with the database. So it's very lightweight what we're doing in the rendering tier.
I just had a quick follow-up comment to your question about single process. The trick you need to remember when you're doing single process is that you define an entry point that can do proper signal handling. If you don't define an entry point, it goes to the shell, and it's especially troubling with Java applications to get a proper shutdown if it's going through the shell and you don't have it wrapped properly. So make sure you use an entry point script that does proper signal handling.
I'll add on to that. We have traps for a whole series of signals that we proxy to the containers to handle graceful shutdowns and things of that nature.
In the back.
Could you speak a bit about your WebSphere migration?
All right, but when I speak about the WebSphere migration plan, it's coming from me, Keith Kreisel, not from Cars.com. You know, it's there and we want to do it. It's just when we do it, I don't know when it's going to happen. We definitely want to get off of it. We've been utilizing Spring Boot like crazy for our local development, and we really want to get Spring Boot inside of a container and deploy those out. As for licensing and when does that agreement get up, you know, I don't know because I'm not privy to that stuff. But if I said tomorrow, yeah, I'd love to get off of it tomorrow. I mean, I can't tell you, the three of us standing up here, how many class loader problems I've had to deal with, and just different JREs and JDKs. It's just a nightmare. So I would love to say by the end of this year we actually get the momentum of moving it off.
So also just to add to that, we did try to get some of the Java applications that are currently running on WebSphere also run on Tomcat. I mean, if you try it, you will also get into class loader issues and Hibernate issues, REST framework, whatnot. So to kind of eliminate that problem, and if the migration starts, we did develop specific Tomcat images that have some open source libraries that will let us run application that natively runs, well not natively, but runs on WebSphere application server just with tweaking the class loader settings. We can also run it on Tomcat.
How do you handle coordinating the rollout of containers versus the rollout of schema or data changes to data store?
That's a very good question too that we haven't had to encounter yet. Oh yeah. So Daryl, the question was, how do we coordinate the rollout of the containers with the rollout of database schemas and make sure all that's in sync? What? Bruce. Oh, there you are, Bruce.
We're not yet. But we got a plan.
Why don't you come up here and talk it in the mic?
Tell us the plan.
This is Bruce, our data architect and our DevOps architect that's actually working on this right now. Put him on the spot.
So like he said, we're working on a plan to add our database deployments to our continuous delivery pipeline, and we're going to automate our deployment of DDL scripts and create a schema version and add dependencies through Artifactory to manage that.
Do you have any good ideas since you brought it up? Yeah, I've been toying around because we still have some issues like when applications depend on other applications, or in this case depending on the databases, like how do you register the dependencies between the two, and we're definitely exploring that right now. Yeah, and how do you roll them back exactly? So we are looking at stuff right now, and we're just kind of playing around with it.
How are you distributing containers across multiple hosts?
How do we distribute containers across multiple hosts? Do you want to take it?
Deep.
What? Deep, you got it.
Yeah, so like I showed on the Jenkins pipeline, all our Jenkins jobs are basically pulling the images from the registry and then just using PowerPoint, we're starting those containers.
So are you then having to go out to each host to start the containers, or?
Yes, so the jobs are configured to go to every host and do that.
The job's configured to go to each host?
Yes.
Okay.
Yeah.
So you don't have to log on to each host? or-
No, the jobs will do that for us. Yeah.
The Jenkins slaves are the target.
Not really. The jobs, it doesn't matter where it runs, doesn't matter for the slaves, but the scripts are being run on the Docker host itself. So the Jenkins slave will log on to those Docker hosts. And then run the PowerPoint scripts from there. And like I mentioned earlier, the PowerPoint scripts are available using Chef on any of our new Docker hosts.
There you go, deep.
That's what it is.
The flip side to the how do you keep the database in sync question with how do you have you given any thought to how you're going to sort of version and manage your HTTP API calls over time? Are you looking at like Swagger or something similar as a way of documenting
Yes.
those?
Yeah, so how are we documenting our HTTP APIs, and are we using Swagger? Yes, we are using Swagger. It's a great tool, especially because we used to keep our whole registry on a wiki page. So anytime you need to go update that or see that, I bet you guys can imagine how many times that thing got updated. So you're like, hey, look at this call's in here. No, it's not. But yeah, we're definitely looking into that, at least for the Java applications. We'll see what's going to happen if we go down Golang or with Node as handling our services too.
Mac had a workflow I wasn't familiar with that get aware, that shell was get aware, and was that Z shell with
Not bash.
that was all
I really kind of hate
Can
that.
you share
But
dot files with us? Or?
my dot files are on GitHub. They're not there yet.
I think you can link to it through the cars.com GitHub, and you'll find all those files. Yeah, also, if you want any Vim tips, Immutable at cars.com will be able to help you.
Or if you want to play Big
My dot files.
Yeah. We also have
There's a readme.
yeah, we also have IntelliJ. A lot of IntelliJ fans in this house, so definitely have any questions or tips that can probably help you out. And then Z Shell, I know there's a couple people that like Z Shell. There's a bunch of us that are Tmuxers in here, so.
Yeah. I like my software 30 years old. I don't know about that.
It's like a fine line, you know?
I make an exception for Docker. It's kind of cool.
Anything else? Going once. Well, going twice? All right, sold. I hope you guys had a great time tonight. Whoop.
We have food, we have drink.
Yeah.
Somebody raised over there too.
Who, do you have a hand?
I have a hand.
Sultan? There's still pizza and beer and pop available, so we'll probably stick around for the next 10, 20 minutes, so feel free. I know the guys on the couch over here probably had a great time over there with the beer, always cold by them. Thank you again, everyone.
We're hiring, by the way. If any of this sounded interesting, come talk to us.